This is Engage New York, Module 1, Lesson 9. Today, remember our objective today is we are going to add decimals. We're going to add decimals using place value strategies and relate those to the written method. All right, here we go. So problems 1, 2, and 3 are right here on this page. We are going to practice adding 2/10 plus 6/10. So 2/10 plus 6/10, if we had to line this up, so here's 2/10 plus 6/10, we would end up with, show me with your fingers. Yes, you are absolutely correct, 8/10. Now, problem 2, 2 ones, 3 thousandths, so 2 ones, 3 thousandths, plus 6 ones, and 1,000th. Let's write that out and take a look at it. So 2 and 3 thousandths plus 6 and 1,000th. Now we're just simply going to add. There you go. So problem 2, we simply lined everything up and we made sure that our decimals were aligned. So we knew exactly how to add them up. Now, finally, on problem 3 here, 2/10, 5 thousandths plus 6/100ths. All right, let's line this guy up and see what we get. So 2/10 and 5 thousandths, and we're going to add 0.06. Now, it is perfectly okay to add that other 0 right here so that your number is balanced and it's easier to keep track of your numbers. Simply add. All right, that is our answer. So now I'm going to, here's our number. Now I'm going to take this number and I'm going to put it into a place value chart. So 1 whole, 8/10. Now I'm going to put 1 whole and 3/10. 1, 2, 3. So can you see that? Give me a thumbs up if you can see that well. Now, if I were to add these two up from here, now what we know about addition and what we know about subtraction, we're going to use the ideas of what we know about addition here. So if I have 8, 9, 10, if I could grab all of these. So remember, when you grasp all 10 together, you have to move it over, right? So if we were to move one more whole over, I would be left with 1 left here. 1 would carry down here. And now I have 1, 2, 3 wholes. 1, 2, 3 wholes over here. So if you can see what I did by using my addition strategies, I grabbed all 10 and I moved 1 full 10 over. Now I have 1, 2, 3 ones and I had 1 left over. Now let's relate that to our standard algorithm. So 8 plus 3 is 11, right? I have to add a 1 over here, and I end up with 3.1. See what I did there? All right, so moving on to problem 5. 100 8/100ths. So 100 and 8/100ths plus 2 ones and 400ths. So let's go ahead and let's put this number here. So 100 and 8 hundredths plus 2 ones and 4 hundredths. Now, over here, we are going to have to use a place value chart. We're going to do, here's hundreds, tens, ones, tenths, and hundreds. Okay, remember, you're taking notes just like this because this is going to be the requirement to do both of these to prove your answer. This is evidence. So now, if we go in and we place our numbers in here, we have 100, we have 0 tens, we have 0 ones, we have 0 tenths, and we have 8 hundredths. Okay, that's our first number. Then we have our second number, which is 2 ones and 4 hundredths. 1, 2, 3, 4. So now we want to try to combine these and create a 10 and move the 10 over. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to grab this 10 and I'm going to move it over, and we're going to add 1/10 here. How many are left over? 2 are left over. So what is our new number? We have 100, 0 tens, 2 ones, 1/10, and 2 hundredths. So let's see if we end up with that over here. So 8 plus 4 is 12. I'm going to add. We're going to take a 10, grab it, and put 1/10 over here. Bring down. Record our decimal. 2 ones, 0 tens. So did we end up with 102.12? Yes, we did. So moving on to problem 6. Now, 48 thousandths plus 7 ones and 13 thousandths. So let's first figure out what our number looks like. So we have thousands and we have ones. So we're going to have to record 0.048 plus 7 ones and 13 thousandths. Okay, now let's go to a place value chart and let's record. Here is our ones. Here is our decimal point. Here are our tenths. Here is our hundredths. And here is our thousandths. Okay, now let's place these numbers in here. And I like to use different colors to remind myself of where my numbers are coming from. So I have 0, 0, and then I have 4. 1, 2, 3, 4. And then here I have 8. 1, 2, 3, 4, 5, 6, 7, 8. And I kind of like to use the idea of an array because it helps me see the numbers a little more quickly. Now here I have 7 ones. 1, 2, 3, 4, 5, 6, 7. I have 0 tenths. I have 1 hundredth. And I have 3 thousandths. Now here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because I'm adding them up together. I'm going to move this guy over here and add one more tenth here. 1/10 is left, so I have 1/10. Then I have 1, 2, 3, 4, 5, 6. I have 6. No, write that down as a 1. 1. Now I have 6. I have 0 tenths. And I have 1, 2, 3, 4, 5, 6, 7. I have 7 ones. 7 and 61 thousandths. Now let's go over here and check it. 8 plus 3 is 11. I'm going to add 1/10 over here. 4 plus 5, 6. 0. So 0.061. All right, last couple problems. We're going to do exactly the same thing with 7, 8, and 9. So let me see. I'm going to let you go ahead and try it. I want you to try these 3 problems and come back and check your work. And that way I'll know, it's kind of like your exit ticket to let me know how you're doing. How did you do on problem 7? Were you able to add them? And were you able to use the place value chart to show how you grabbed a 10 and added the 10, and grabbed a 10 and put over a 10, 1/10. So the 10 tenths becomes 1 whole. All right, let's talk about this problem set really quick. So in our problem set, here we go. So solve and then write the sum in standard form. Use place value chart if necessary. So you're going to write what is 1/10 plus 2/10 equals, show me with your fingers. 1/10 plus 2/10 equals 3/10. Nice. Which is equal to, let's see what they want there. Can't remember offhand. Oh, so then write it in decimal form. So you're going to write it 3/10. And then, 3/10, and then you're going to write 0.3. So you're going to write it in decimal form here. Okay, then using standard algorithm, 0.3 plus 0.82. Yes, add that 0 to balance out your problem. 1.03 plus 0.08. You're going to add, make sure to write your number here on the back side. Same thing using standard algorithm on here. Van Cortlandt Park's walking trail is 1.02 kilometers long, and then it's longer than Marine Park's. Central Park's walking trail is 0.242 kilometers long, longer than Van Cortlandt's. Fill in the missing information in the chart by placing the numbers in the chart. Then solve, if a tourist walked all 3 trails in a day, how many kilometers would he or she have walked? And then Meyer has 0.64 gigabytes of space remaining on his iPod. He wants to download a pedometer app, which will take up this much space on the iPad. A photo app takes up this much space, and then a math app takes up this much space. Which combination of apps can he download? So you have to play around with these numbers to figure out he only has this much remaining. Which one makes the most sense for him to download, because he wants to get as many apps as possible without going over his remaining gigabytes.